Far. I'm from the Hackery in Philadelphia. Hackery is a hackerspace just started up there about 6 months ago. It seems like there's like 9 or 10 spaces just starting up now. So we're just one of the many, younger guys who are pulling stuff together and trying to do the community stuff. Before I get started, they have these really cool random announcement cards. You just like sort of pick one and yell one off. I kind of like it. So anyway, yeah, cell phones, you can turn them off. I turn mine off. That'd be cool. DVD sales of all the talks are also available from previous years, and then this year's are going to be online and things like that. So if you weren't bored enough here, you can watch it again and, I don't know, help you go to sleep at night or something, whatever works. So I'm going to talk about community fabrication. So I'm going to start with my credentials. I am, as you can see, well prepared to talk about this. I spent years studying this topic, and I didn't just get interested like 3 or 4 months ago and just finally get a Fabber like 3 weeks ago. So, it's an early morning talk. If you guys fall asleep, don't worry about it. I won't tell anybody. So I'm pretty gung-ho about this stuff, although I haven't had a lot of experience, and frankly, they couldn't find somebody with a lot more experience to talk. So I think probably in the audience in the building somewhere, there's someone more qualified than I to speak. If, catch up with me afterward, correct me on what I've done wrong, yell out during the talk, whatever. Oh, great, see? So they must have just put me in as filler this morning then, so they could, I've been downstairs babysitting the hackerspace for the Hackery, so unfortunately I've missed those talks that have happened already. So, I'm going to talk a little bit about the community aspect of it. It sounds like people have already covered some of this sort of thing. So yeah, what is community fabrication? Fabrication is, building things, fabricating things out of hardware. Community fabrication is the idea you have somewhere you can get to do this that hopefully isn't, like a huge cost facility. Hopefully there's an idea of exchanging ideas. It's not, locked behind doors. It's about not only the ability to grab the tools, to use the tools, to learn how to use them, but to bounce around ideas, to communicate with people. There's a lot of things that you can do as an individual, but I think people in the software community are coming to realize pretty hard that when you have other people to bounce ideas off, when you have other creativity, when you have other angles on the same problem, you can come up with totally new, totally cool solutions. There's some examples of existing projects that are sort of the community facility style of this. South End Tech in Boston is basically a little tech community center. They have a bunch of fabrication tools that I'll get into a little bit later. They're sort of aimed at students. They're aimed at an outreach program. They came out of the MIT Bits and Atoms program. And the idea is, the outreach for getting these technologies for building stuff at the campus was to take it out and, get kids hands-on and teach them some stuff. It's turned out to be a really big success. Kids come and they build really amazing, cool stuff that people would not have thought of otherwise. It's just out in the community. It's like a community center. Sustainable South Bronx is right here in the city. I don't know much about it. If anybody does, feel free to yell out. As far as I understand, it's another one of those centers where it's a community center. It's tied to a school. There's a lot of community colleges around the U.S. in Michigan, Iowa, places like that, that are building this sort of a fabrication lab at their school. Some of them are doing a really cool job as a community college and making it very accessible to people in the area. Some colleges, not so much. There's a bigger barrier to entry. But that's another set of the sort of, in the community, out there just floating around. There's also, the commercial versions of this. There's Tech Shop out in California. They're building like 8 or 9 new places across the U.S. in Seattle and North Carolina. They're building a couple more in California now. It's like a tool gym. You go, you rent the equipment. I've stopped by and I've checked I checked out their San Francisco location, and they're pretty cool. It's not, it definitely is a paid gym. It definitely is someplace you're gonna have to, put a couple bucks down every month to get into, but you can get in, you can do stuff. There's a community aspect, there's lounge areas, people are really friendly, people are really helpful. There's Crucible, there's a lot of little random places that sort of fit into this that are not coming at it from a fabrication end, but are coming at it from a craft end. There's woodworking shops all over the place. There's places that do ceramics, things like that all over the place. To me, these all sort of fall into the fabrication chunk of things. Yeah, maybe they're not making things out of plastics, maybe they're not making high-tech stuff, maybe they're just making stuff to sell on Etsy, but they're making stuff. There's a knowledge base there, there's skills there, and there's the idea that hey, bouncing ideas off, working around, we can do stuff better. I think we can pull ideas from all these guys as we pull the hacker aspect into it, and as we start to look at okay, well, what can we mess with? What can we tear apart and rebuild, and what can we figure out? So for the modern Fab Lab, there's sort of like 4 main style of tools that it really kind of takes all of them together to make a really, it's sort of like, you know, critical mass. One is the laser cutter, plasma cutter, water jet cutter. They're basically, it's a sheet metal cutting. You get a substance, and then you can cut designs out of it, out of a flat thing. And then of course you can stack those, you can roll them, you can deform them other ways. But the cutting of a sheet surface is like tool zero. CNC machines for cutting a block of material down are another big thing that it's sort of almost every space needs to have. You get whatever it is, wood, metal. You can use a CNC machine. You can set up, program things into the machine, and it cuts it right out for you. There's a lot of layers, a lot of variety of this. You can get a $5,000 machine from Sears that'll get you started, or you can get the $100,000 Pro tool, takes up a whole room. There's a whole range of these things. 3D printers are what I'm interested in. That's basically depositing material to build up a structure over layers. There's a lot of unique problems. It's kind of cool. The other tools like laser printing CNC or laser cutting CNC machine, like there's sort of people have been doing that for a long time. There's been a lot of tools like that around. The 3D printers are a new tool that's coming out and just getting accessible. Since the 60s, you could go to Bridgeport and you could buy a mill, or for the last maybe 10 or 15 years, you can go out and you can get a water jet cutter, and they're out there, they're available. The 3D printers, they're finally getting to the price range where guys can get them and just have one in their basement, or a couple guys can chip in to have one, somewhere where everybody can get access to it. And the last is the electronics end of things, like PCB making, rapid prototyping, having the electronics expert to run the motors, run the electronics. You can build a lot of cool devices with just hardware, but it's the hardware-software combination that really pulls it all together. So it's turned out that the expertise in software, the expertise in microcontrollers, soldering, all that stuff, laying traces, electrical engineering, that's become a big part of fabrication. And in Philly, we see a lot of artists who are doing installations coming to take our classes in software, coming to take our classes in programming, because they have this really cool concept. They've actually built most of the rig, and then they're like, oh, I don't know how to run the motors, or like, oh, do I get an 18 volt or a 16 volt or a 14? Like, they're coming to us to ask those questions, and it's sort of weird that there aren't better resources out there. And of course, we're going to them and we're being like, oh, dude, we're building this really cool thing, but we don't know how to physically make things. So there's a weird cross convergence, at least happening in Philly. And I think that from what I'm hearing from other people, it's happening all over the place. But these are the main tools that really make a modern style Fab Lab. And this is like the main list here. So the functionality floor, there's a lot of places this can go. Things have been sort of like rolling around. These places are building up, and I think it's finally getting to a critical mass where it's going to sort of shift in one direction or the other. The bare minimum that this technology, mainly the last 4 tools, are going to cover is going to be basically what we have today. I don't think it's going to fall any lower than this. I think this level of stuff is going to be around, which is you got little groups of guys who chip in to buy a tool. They're specialized. They do just like, oh, this is just woodworking, or oh, we're just metalworking, or we're just welding. There's company fabrications or university fabrications where it's only the company, it's only the university. You have to be a member to get at it, which there's several in Philly, which drives me a little crazy. It's for design studios. It's expensive. It's exclusive. This is what we have now in a lot of places. There's very few places where you have the open shop style. Then there's the ceiling. Like, how high could this go? If this like shoots off and goes crazy, what would happen? One is like Fabrication Everywhere. It's like Kinko's. You walk in and you want a part for your blender. You're just like, hey, give me a part for my blender. They have a file somewhere. You pull it up. Custom-made stuff is really easy. You can just go in and you can just pull what you want. You have your name engraved in everything. You can have your name cut into anything, pulled out of anything. You can make a sculpture of your mom's face for a mug if you want your mom's face on a mug. Recycled reusable materials. There's a lot of people talking about the potential for the polymers, a lot of the plastic extrusion and 3D printing, or the materials you're doing your cutting or your CNCing out of, to be totally recyclable. Like, you go and you build something and it breaks, you walk back and you just like drop it in a bin. It, behind the scenes, some machine chunks it up into little parts and combines it with an epoxy and pulls it back out. Like what they do with the roads, macadam. They'll tear up a street, they'll reprocess it, and they'll lay that same material right back down, sort of refreshed for more use. A lot of people see that like the local fabrication shops make this a possibility, because you're not shipping things way far away and way back. Like, right there, you can drop it off, wait an hour, and you can just chop up your coffee mug and then have a better coffee mug with a nicer design in a little bit. Cheap customization, cheap repair. I think that's covered pretty well. The idea that building hardware will be as easy as building software. That you can go in and you can like build something. If it's wrong, you're like, oh well, who cares? And just make another one. And that's to me, that's a really powerful idea. I've built, I'm kind of a hand tools type guy. I like to build things. I've built a lot of my Christmas gifts. I build a lot of stuff for my apartment. And there's a lot of times where I mess things up and I have stuff that's at a weird angle, things like that. And being a software guy, I'm like, oh man, I should have measured 3 times instead of just building it, because as a software guy, I can just build it, and if it doesn't work, well, who cares? It'll take 3 seconds to change it. When you start to get into physical stuff, those rules change. And to shift it more in the direction of you can prototype fast, you can just throw stuff out and pull it back together. I think that'd be an awesome thing to have. Fab in space. This is one of the things that I don't hear people talking about that I think is just damn sweet. Is like, we're gonna get into space, we're gonna need to build things. It's pretty obvious that fabrication technology is going to be a big part. You can't ship every single possible part up to Mars. You're going to need to ship up a box that can make those parts. I really think that we need a backup system that is not on the big blue marble. And I really think that some of this technology, I have hopes that one day I'll tell my great grandkids I worked on that one with a bunch of crazy guys, and now it's in space, and when the planet goes out of orbit and gets eaten by the sun or space monsters come, somebody will live on. So my big question with the functionality ceiling is like, does this come like a Linux users group style, like guys pull together, girls pull together, people pull together, they just make a space? Or is it going to be like Kinko's? Is some big company going to go out and say like, oh, I realize there's a market need for this, and fill it? Right now we're in the space where it could go either way. There's community groups, there's people just buying the thing and calling their friends over. There's places like the Hacktory, there's places like New York City Resistor that are buying RepRaps, that are buying FabAtHomes, that are just making the tools available. There's also places like Tech Shop, and there's nothing wrong with it. They're just, their style is they're going to do a company, and they're going to make money. And I sort of feel that the next couple of years are sort of going to be a breaking point to see if Tech Shop can make a like commercial enterprise, or places like that can make a commercial run for it, or if it's going to sort of fall into the community group hands. So I'm going to talk a little bit about 3D printing, because that's something I know at least a little bit about. So this is basically rapid prototyping by extruding layers of plastic. If someone is talking about a rapid prototyping machine, they're usually talking about like a $60,000 to $100,000 machine. These are the stuff that design studios have, that architectural firms have, that the big places that do industrial design have in their offices to put out their samples. They're very high precision. The plastics are usually a little bit more rugged. They get a lot of use. They cost a lot to maintain. These systems are really closed. If you want to, make something out of a new material, you want to experiment with chemical materials, things like that. These systems, a lot of times, they won't support it. If you jam it up because you're trying some new plastic that you invented, they're just going to tell you like, oh, well, it's not covered under your warranty. You have to pay for the repair, stuff like that. The next step down is like the 3D printers. This is starting to get in like hobbyist affordability, although it's really, the high end of that. Strata Dimension BST, as I understand, is sold out for like the next 2.5 years, 3 years. They're making them as fast as possible, but people are buying them up just as fast. Z Corporation, I don't know much about their machines, but it's another one of the desktop models. It comes with their software. You're using their plastic. 3D Systems, same idea. Like it's in a box, one-touch solution type of thing. You just drop your CAD models and drop them in there, and they deal with maintenance. They deal with that stuff. Below that is like the do-it-yourself level, fabrication stuff. There's FabAtHome, there's RepRap, there's Clanking Machine. Clanking Machine is going to be the lowest. That, like, in theory, you could build a clanking machine for like 300 to 600, and that's just basically you get the raw parts, you build it yourself. That project is still coming together a little bit. It's nearly there, and it's going to be out soon. FabAtHome, they just put out their Generation 2 machine. They have a box. It has a couple syringes that are extrude material. It lays down layers. It's not as precise as the huge commercial machines, but you can put anything you want in there. You can try new materials. You can try doing things like replacing the head with a printer head because you want to print different chemicals. You can, guys have refitted it with like a candy Faber style melter, so they can like put in a substance and then melt it down rather than extruding a substance on top of layers. It's really easy to open up and mess with. And RepRap is the same way. RepRap's goal is to make a machine that'll replicate itself. Same sort of thing. It's simple parts. All the parts should be made out of the same plastic they make. They actually did like Replication 0, They took one RepRap and they made a second RepRap, made all the plastic parts for it. They had to cut down the metal and do a little bit of the engineering work a little differently, but you know, a RepRap can basically make itself at this point. So the 3D printer's dream of where this could go, this sort of goes also with the floor ceiling thing, is you know, world domination. Like this could be the thing that saves everybody. And you know, green technology, face down mass production with localized production, and you know, it would be cheap and easy to produce here. Get us into space. You know. Sustainable local production of goods, like local economy, having the guy making the stuff a couple blocks away instead of across the planet. All that sort of, you know, feel-good type stuff. Teach our children, wash our clothes, shave our cats. Just, you know, solve all the world's problems in one go. And this is what a lot of the guys are talking about. And I think it's out there. That could happen. That could be what I think there's a good case for that. And I think that's what people talk a lot about. What I'm sort of interested in is like more of like what's happening now. 3D printing is a little bit difficult to use. It's really cool. You can make some really good stuff with it, but like it's not trivial. It's not you just press a button and stuff pops out. You have to, you know, you have to mess with syringes. You have to mess with the plastics. Stuff doesn't print right the first time. You have to go back and try again. It's not, you know, it's not just totally simple stuff. You do need technical skill to run this stuff. The software is a little wonky. Sometimes you have to go in and look at the math and figure out like, okay, what's going on with the paths? Why isn't it connecting? You know, like you can press the connect button, it doesn't work. Okay, well, fire up the debugger, hit a couple breakpoints. Okay, well, this is what's wrong. You know, like it's not there yet. There's a lot of work that's going into it still. It's not really something everybody needs. This isn't really a blender that people are going to use every day. Like, you know, a lot of people have talked about like fabricators in every home, and you know, yeah, there's a chance that could work out. Like, I'm not foresighted enough to see that, but it seems like this is more of a technology you're going to use once in a while and random, you know, one-off type stuff that isn't going to be for everybody. You know, not everybody has a milling machine in their house. Not everybody has a lathe in their house. Not everybody has wood cutting materials. But they're really great to have. You can do awesome stuff with them. They're fantastic technologies, but you know, they're not, you know, turning the world around. It is just getting traction. Like I said, the fabrication stuff. They're building software now. On the mailing list, you know, for FabAtHome, they were just like, "Hey guys, let's make this cross-platform," and I'm like, "Yeah, it's probably a good idea. Not Windows only, please." So like, it's still at a stage where you can get in and you can steer the technology, and that's part of the reason why I'm interested myself. Is that I'd like to get in and I'd like to push this towards being open. I'd like to push this towards accessibility. You know, I'd like to make this stuff available or help make this stuff available. You know, either way the technology goes, at least, you know, I'm sort of pushing in one direction, I guess. Yeah, this might go big, it might go home. You know, people compare it to, let me go back one. People like to make comparison to like computer technology in the 60s, like, oh, it's gonna, you know, we're looking at it right now, it's the geeky guys with their little clubs. There's gonna be one in every home. People underestimate the power of it, people underestimate the ubiquity. You know, that's the model that a lot of people like to talk about, is like, oh, it's like, you know, the homebrew computer club in 1960. And, you know, when I actually signed up for this talk, that's what I thought too. In the last month and a half or so of messing with things, I'm thinking it's more like Linux in the mid-90s. Like, yeah, you know, it could really be something, but it's not there. There's a lot of talk, there's a lot of hype. But frankly, you're not seeing Linux desktops on everybody's machine these days. You know, it runs the backbone of the internet. There's a lot of small devices coming out with it, but it's not, you know, it's a little different. It's a little more technical. It's a little harder to deal with. It's a little, you know, takes a little bit more to dig into. Takes a little more skill to make it happen. That's sort of the overview of like 3D systems. I'm realizing now I'm burning through this really fast, so this may be a really short talk. So I've been using FabAtHome. That's the system that the Hacktory decided upon. We looked at RepRap, we really liked it. Evan Malone actually came and spoke at one of the events in Philly, and we talked to him, and he was pretty gung-ho, and you know, we made the hard decision and decided to go with FabAtHome. FabAtHome only officially has a Windows framework. Yeah, I was actually on the bus coming down here, exchanging emails with people about like, hey, let's make the open source version of the framework the official framework. Let's move everything into Boost. Let's move everything so it's cross-platform. You know, it's really weird to see this technology that's like cutting-edge next generation technology, talking a lot about openness, making source code available, and then it only runs on one platform. So Software and hardware are a bit obstinate. It is a little bit hard to get it to do what you want it to do. It's not, it's not just print this device. You have to home the machine. You have to set up your coordinates. You have to make sure that your models are right. There are times where you load a model, you set it up, and it won't go. So you have to go in and you have to figure things out. Like it's not trivial. But to make up for that is there's an awesome community behind it. The guys that are doing these projects, the guys on these mailing lists, the guys in the fabrication forums on the 15 fab sites out there are absolutely awesome. It's a lot like I said, I think it's a lot like the Linux community. Like they're rabid lovers of the technology, and you ask any question and somebody will get back to you with an answer, somebody will figure something out. You have obscure weird stuff and everybody's right there chipping in, giving you a hand, like trying to help you figure stuff out. It is a little expensive to get rolling. FabAtHome, I think a little more so than the RepRap, and both of those more than the clanking machine. You have to put down some money to get one of these and to get it going, or you have to put in quite a bit of time building things. And there is definitely a barrier to that I would like to see lowered. I don't think it's going to fall overnight, but I do think every revision they do of a machine, they cut a few things down, they simplify it, they figure a few things out. And frankly, these things are sweet. Like I'm complaining about them a little bit, but it's really awesome. You go in and you set up a 3D file and the thing comes out. We're talking with a couple people about what uses we can put this to, and I lost video. And like frankly, I don't have anything useful to do with this. I just like making stuff. So I'm like making just random things for the hell of it because that's what I enjoy. We lost video, I guess. So since I don't know about RepRap, I want to open it up. Does anybody here use RepRap? Is anybody familiar with the RepRap systems? Okay, cool.
I've got a bit of a crack at it. It's quite fun.
Say again?
I help with some of the, I think it's one of the monitor tracking things.
Cool. So,
but it does seem quite good because it runs on Arduino, which is pretty much seems the de facto standard now for most things.
cool. And is it working up to expectations? What do you see it doing in the next year or two? How are things going?
It's been a bit of time since I followed it
Cool.
properly, but
Cool.
when I last looked at it, it seems to have quite a bit of progress. When you mentioned how it built itself,
Yeah.
I think it's probably come on a bit more.
Sweet.
Now, because that's a months back now. So yeah.
Awesome.
You guys know if they get the standard output files from a lot of these ProE or standard CAD?
Yeah. All of these except standard STL output files. There's an open source program called Art of Illusion, which is Java based. It runs pretty well on several different platforms. That really, it's pretty easy to operate. You can actually do Blender 3D too if anybody has Blender experience. You can tweak some parameters in Blender to make it a little easier to use, and you can build the models in Blender. Art of Illusion, both of those are free. 3D Studio Max, things like that will all output STL files that are read in. Some of these things, it won't warn you if your design is too complex or things like that. It'll just generally try to make it. But you do need to have sort of like blocky, simplified designs. You can't do anything too fine-grained with these machines because their precision isn't there yet. They're still, it's still being worked on.
How do they measure the precision of granularity?
Usually millimeters, plus or minus half millimeter, things like that. So, I think the FabAtHome, the best I've gotten is like plus or minus half millimeter. I think people have gotten it more accurate, but people have more experience than I. So. Sure.
I've used rapid prototype machines around university.
Sweet.
And to do a lot of stuff, you have to take into consideration the grain correction. It's really weak in one direction.
Yeah.
I've never used one at FabAtHome, so I don't know if that's still an issue. And then also, like I've done just a 3x3 cube puzzle that took like 18 hours to print.
Yeah.
So I don't know, like that's kind of a barrier.
Yeah, definitely. And it's definitely it's not a perfect technology. It's still growing, and I think that's so your cube, did you design that like just out of STL files and threw it together?
In SolidWorks, and asked for it as STL files.
And you said 18 hours?
Yeah, it was several cubes.
Nice.
Yeah.
Sweet.
Has anyone done an actual cost benefit, referring to the greenness of the project, has anyone actually done a cost benefit analysis on how much energy is used? Like, if you compare like a RepRap to, say a RepRap uses 100 joules
Yeah.
to make a thing compared to a factory that uses a megajoule, but it puts out 1 million a day, and then it costs 10 megajoules to ship
Right.
You're still talking about an order of magnitude more energy to produce it on a RepRap
Yeah.
versus even though you're not shipping them, because the demand for the stuff is still there. And if everyone goes out and gets a RepRap,
Right.
then you increase the energy usage by an order of magnitude.
Yeah, exactly.
Has anyone done any studies on this?
I've seen, I've actually talked with guys and done some back of the envelope calculations, but I don't think there's been any real official study on this. And the general agreement is also like this stuff really isn't green right now. Like there's the potential, there's that like pie in the sky, we're gonna get there, and there's totally a chance. That's what I'm voting for, but it's not there yet. A lot of the materials they're using are kind of nasty materials. You read the MSDS sheets on this, and it's like, I don't really know if I want to be breathing this in too much. I'm gonna turn on a fan. They're really cool stuff, but it's that's something that needs to be worked on.
You said they're nasty materials. I know I guess the tradition for RepRap machine is the first thing you drink is a shot glass and take a shot out of it. Is that?
No, it's like once they harden, they're not too bad, and like I don't think a little bit of material from like taking a shot glass or like eating off of something. I've printed things, then I print some chocolate thing, and I'll eat the chocolate because I use chocolate for test printing. But it's the sort of thing where like if you're making 40 million of them, or if there really is one of these shops on every corner, like what happens or what does that add when everything comes out?
Just talking about the green benefit, like I've visited a lot of factories and seen a lot of injection molding stuff. And for a lot of medical equipment, things that are just like syringe size, half the size of this room just to do that. You have such an incredible infrastructure to do this kind of stuff. You'd have to take into consideration like how much energy goes into processing like to make those things. That unless you're making billions of them, you may actually be better off printing.
Oh yeah, for small parts, obviously, but I mean, I have a hard time imagining how we could ever get a rapid prototype or 3D printer machine that is so efficient that it can beat out like Chinese mass production. Because I mean, the whole point of mass production is that overall the cost is massive, but the cost per item is tiny, so that obviously takes into account energy as well. So for stuff like that, like one-off printing of repair parts, I don't beat that. But beating like Chinese Disney toys that they make 10 million of them and sell 1 million a day, I have a hard time seeing any 3D printer beating that.
And back a little bit to the materials, I think the RepRap also have a lot of the stuff they've done in terms of materials. They're using polylactic acid, which is biodegradable. You can synthesize it out of cornstarch.
Very cool. Very cool. Excellent. So basically, when you're done, you can chop back up and it'll biodegrade, or do you need to do other process to? Sweet. Oh, that's excellent, man. Yeah. So yeah, I think there's potential. This is exactly what like my interest in it is because I don't think it's a one-shot solution. I think that right now the technology is growing, and I think that the hacker community should get interested in steering it, because Linux is an awesome tool. It's out there. Anybody can grab it. It has given a lot of power to a lot of individuals. It has pulled, it has leveled the playing field. Like you can learn stuff. You can get access to knowledge. You can get access to tools, using Linux that you can't get otherwise. Art of Illusion, Blender, things like that. They're tools on top of tools. I think a lot of these other 3D programs wouldn't have happened unless somebody looked at Linux and was like, oh, dude, you can actually pull this off. And for me, like that is what I see my interest, and I hope to get that interest sparked in other people to be like, all right, the technology's here, and we gotta we gotta lean it in the direction that is cool for us, that gives us the ability to make what we want, to figure out what we want, to play with what we want, rather than like letting it just naturally lean towards some commercial system where you have to ship it off to Iowa to get repaired if you play with something you're not supposed to play with. So yeah, I don't have much more slides. I really wasn't expecting I would have a whole hour for a talk, so I didn't plan a whole hour for a talk. I was wondering, if people want to hang out and talk about this, does anybody else have comments or ideas on this? You want to grab the mic, dude, since you're in the back?
I was just wondering about your space in Philly. 2 questions. Do you have a legal structure, and what's the listing thing?
Okay. We do not have a legal structure. We are umbrellaed under a local nonprofit. We're trying to figure out, frankly, if we want to do an LLC, or if we want to go for the nonprofit status and do like a 501c3. Nobody's going to really make any money off of this. Like, I don't think there's potential. It's just a lot of fun. but there is, you know, even internally an argument whether we want to officially do that and say like, okay, officially in the rules of how we operate, it's nonprofit, or just do an LLC and expect to never make any. The coolest thing we haven't made very many cool things, to tell you the truth. We've only had a 3D printer about 2 weeks now, so we've been doing a lot of test prints. You know, we've made, you know, blocks of letters. Craftmark is actually really cool. It's in King of Prussia, like a half an hour away. So I have a box of Craftmark demo materials on my desk at home that I can't play with because I'm here this weekend. But it's really nice that it's small enough that like I email the manufacturer, I'm like, hey dudes, you're right nearby. They're like, oh yeah, you want to play with stuff? Here's a bunch of stuff. Like, so next year I will have a much better answer for that question though. So, there's another guy back there that
You sort of hinted that you feel that the technology might not be that useful yet, and you talked about making it more accessible.
Yeah.
I was wondering if you have some thoughts about sort of what it would take to make the technology more useful, and are there efforts being made towards that?
Yeah, right now there's sort of two things, and one is the software and how sophisticated it takes to use it. I think is barrier, you know, is the most obvious barrier, and the other is a material science question. There are a bunch of materials people are using, and there's a lot of expansion in other materials. You know, the FabAtHome wiki has pages of like, here's an idea of what to make. Here I tried it. It kind of worked. Here's an idea of what to make. Here I tried it. It really worked well. People right now are out there basically like pushing out in all different directions on the materials and trying to get fast, easy to use materials that can break down. But that is one of the barriers. Like loading the machines up, getting the materials set up is a little bit of a frustration right now. And the other actually is something that people in this room could help with a lot, which is software and firmware. A lot of tools for this were existing tools for 3D, you know, for 3D stuff like Blender or Art of Illusion, or their homebrew software that was written within the last year. That is, you know, a lab got some money, they got a grad student or an undergrad student, and they set the software up. So there's, you know, it's all right there. It's all right on the surface. You don't have to dig very far to find interesting things to work on in the fabrication stuff. You know, I'm going to complain a little more about the software because I'm a software guy, but, you know, the user interface for FabAtHome is just, it's really a kind of a pain to use right now. And there's 3 or 4 people working on it trying to clean it up, but, you know, you load a file, then you load another file, and then you're not sure which loads or which menu it was. You know, there's times where I've hit print and the print button is grayed out. There's no explanation. There's the status bar at the bottom doesn't say anything. It's just that button just doesn't work anymore. So I close the program down, I start it back up, or I, you know, throw open the debugger and start to step through to see where it's, you know, not working. So there's, you know, if people want to dig in, this is a really cool thing to work on. And like your result isn't just something that you can throw up on SourceForge or Fresh Meat. Like your result is a thing you can put on your desk and be like, oh yeah, that's a thing. So.
How long do the 3D printers actually last for? Like how many prints can you make with them before they start to break down? And is that like a concern with kind of doing test prints or whatnot?
Yeah, it's not really a concern. The concern is usually like your material supply. We have like little 8-10 ounce cans of material that it's probably like, I don't know, $15 a material or something like that. So making, you know, and it takes 8 hours to make a print, or it takes 6 hours to make a print of something that's moderately complex. So like the bigger issue isn't is the machine going to wear out. The bigger issue is like, how bored am I getting right now? Because, you know, you start a print and I'll go tinker around the hackerspace, clean things up, put things in drawers, make little labels, solder together proto boards. I come back and it's still printing. I'm like, man, I'm not going to sit here all day. So I go off and I leave and I come back and it froze on an error a half an hour ago, and, you know, I have to restart. So these machines are going to last a long time. They're just built on standard stepper motors, and a lot of them have syringe units that are replaceable. You can pull them out if they get clogged up. You can, you know, clean them. You can throw them out and get a new one because they're just small. And then the chassis around it, you know, those things will last for a long time. But, you know, the bigger thing is like basically the weights and again dealing with loading, unloading, things like that.
You mentioned at the beginning cutting metal, like sheet metal.
Yeah.
What's like the cheapest way to get set up to cut metal, like laser or whatever?
You can buy, so the big barrier on that is what size you want. You can buy from Sears a little $3,000 unit that can do about maybe 10 inches by 12 inches. And it's right, you just go to Sears.com, order it, it comes in. It actually, from what I've heard, has halfway decent software. If you want like a table size, you're going to get to about $5,000. And that's going to be the cutting system without a background table, without the bench base, without things like that. You want all that, it's going to get to about $7,000. I was looking just the other day at getting a, 48 by 30 cutting surface. I was like, oh wow, $5,000 is cheap. But that's just the machining on the top. You really have to have a very stable base to run these on, because the way the motors like slew back and forth, they tend to pull and shake things apart. You can throw together a wooden table, but it's probably going to pull itself apart from the movement in a few months, and you're going to get very much less exact cuts out of it. So again, like $7,000, it isn't much, but is it really something that you want in your own garage, or you want a bunch of people having in their own garage, or is it better to pool it together, get some space somewhere several people can get to, and pool your money, pool your effort, and centralize.
I was wondering if you've heard of the Gingery Foundry. Dave Gingery, it's basically the RepRap 50s. There's a set of books by a guy, dead guy now, Dave Gingery, and it was basically how to set up a metal shop, a forge,
Excellent.
sheet metal cutting, all kinds of metal fabbing, and you build it from scrap, like garbage. You melt. The first thing you build is the foundry. You melt down the metal, then you build the lathe, and you actually build the lathe in steps. And the parts that are built by the lathe are parts for the lathe itself. And it's very similar to a RepRap, but with metal, and it was done in the 50s.
I would love to get. I have to make sure I write that down afterwards. Catch up with me, because I want to grab that. There's two projects that are like leaning in that direction. Two things that makes me think of. One is in one of the Terry Pratchett books, they talk about doors, and like all you need for a dwarf to be successful is a fire. So the fire, he can make a forge. With a forge, he can make tools. With tools, he can make better tools. And give him like 2 years in fire, and a dwarf can make anything. And that's very much the same idea, like bootstrapping up. There's a program that is based on doing that out of old car parts, and it's centered on getting that technology into Africa, where they have scrap stuff that comes down and gets torn apart by hand. And same idea, you start with a drum brake, and you start with just setting a fire under a drum brake, and then you get some of the softer metal from the cars, and you work your first set of tools, and then from there you can build more. So like that idea is, it's an awesome idea, and it's not dead, it's still floating around.
It's an old idea, too.
Yeah. Anybody else? I thought I saw hands up.
Yes, so if I don't have like 3,000 to put into a laser cutter or anything kind of thing like that, do you recommend a scroll saw for cutting parts, or should that be avoided?
Yeah, okay, so the Hacktory in January just got our space donated. The nonprofit that we're umbrellaed under said, we have a third floor, it's completely trashed, why don't you go up there? And I had $50, that's all we had. And our decision at that time is we decided to build a vacuum former first. We got a vacuum former and a jigsaw, so we could make plastic forms and then cut them out and sand them down. From there, in that regard, our next tools are going to be a scroll saw, and we just got a chop saw. So I think a jigsaw is a nice first step tool. A lot of places have chosen, a lot of guys who are doing their own home shops have chosen to go first with a non-motorized CNC machine, and then they build motors onto that. And like that is, they're learning how to use the technology, they're building it themselves, and they're doing it on the cheap because they don't have much off. So yeah, I would say scroll saw probably would be one of a few good options to go with. Yeah. Anybody else?
Do you know anything about building your own CNC machine?
Yeah, I spent quite a bit of time like looking at the different options for that. And frankly, what I came down to is we don't have the time to do that. There's a lot of good projects, and there's several websites out there that are centered on the do-it-yourself CNC style. And it's totally doable. You can just go out and get the machine, you can buy the engine parts, there's software, there's tons of examples. There's guys that do everything from like designing their own boards through you can buy like pre-built motorboard sets that'll run off something like an Arduino or just off a old parallel port. So you can, like the Make controller board, I know I saw one a couple weeks ago, that you just use the Make motor controller. So yeah, there definitely is a good potential for doing that. It's pretty straightforward, but it's a big investment in time. One of the things that again, coming from a software background, like I was sort of overwhelmed at the time it takes to make some stuff. Like with software, if I know what I'm building, I can just sit down, I can do it. With mechanical stuff, I severely underestimated the difference between like knowing how to do something and actually having it done. You know, there's a, to me at least, there's a bigger barrier. You know, like if I know software, it comes out. If I know mechanical thing, I do it and it's wrong. I build a second one. I measure 4 times. Like there's a big time commitment getting into building this stuff yourself.
Do you see any convergence of like the orthogonal tools, the cutter, the CNC machine, the 3D printer, and
The PCB maker and the
and I'm wondering because I know that you can make PCBs on a CNC machine, like 1 or 2 layer boards, using copper clad board, and just like way to settle. And
Yeah.
is there any convergence between like a 3D printer and a CNC machine because both have similar requirements for the movement?
Yeah, I think there's sort of like you were saying, there's like a stepping stone where if you build one, it'll make it easier to build the others. But you know, I don't see them converging like into one machine, and I don't see them totally solving the problem of making the others. That's, you know, one of the things we talked about was when we had a vacuum former, we looked at the FabAtHome, and there's a plastic shell, and we're like, oh, we could like vacuum form the shell or something like that. Like, what tools can you use to make other tools? They're definitely, you know, you can bootstrap probably. If you did it the right way, you could build one tool and pull all the parts from that to build the other. But I think that would take actually a lot of effort to pull off. So.
I was just wanting to say, I know the RepRap has a bootstrap project.
Yeah, RepRap is very cool like that.
Yeah, that's pretty much along the same lines. I know they're starting as like students to do PCBs.
Nice. Nice, that is excellent. FabAtHome has done, they haven't done PCBs, but they've done batteries, and they've done mechanical, basically the dielectric metals that will bend when you apply voltage to them. And there's a couple projects where they would lay down a plastic case, then they would lay down their various metal layers, and then case the top in plastic. And then, you know, you apply electricity to it, it'll bend and turn. Doesn't directly apply to the project itself, though. So. One of the things that I've found kind of hard as I'm getting into this, because like I said, I'm not super qualified to be talking or anything. I'm just started playing with stuff myself. Is a lot of stuff is out there and done, but it's not on the internet yet. Again, like I'm just like, oh, if it's out there, it's going to be on a wiki somewhere. There's not. I'll find some guy emailing me. He's like, oh, I did these 7 things. I'm like, why does no one know about this? Because that would be so useful if I had found out. So I've spent a lot of time in correspondence digging out information about, you know, things that are out there but aren't really publicized yet, or aren't just, you know, right at the end of a quick web search. All right. Well, any other questions? Okay.
Do you know if the FabAtHome, like, how does it do like the firmware stuff? Is it like a G-code interpreter on it, or is it how much second? If it has a G-code interpreter, you can probably hook it up to any other CAM software manufacturing system.
That's one of the things we're talking about. It doesn't. I don't think it has an interpreter. I haven't dug into the firmware much. I've mostly been looking at the PC side software for it. One of the things we have been talking about is doing a central dispatcher. There's RepRap, there's FabAtHome, there's several of these machines, all aimed at the same goal, but they're all writing separate silos of software. It's like, all right, guys, why don't we make it? You know, take a good software design, make a central dispatcher. Your tools, you know, your tools all know how to talk to it. Your interpreters of the STL files into tool paths all know how to send tool paths down. And like that's one of our goals. Again, this stuff is like super fresh. Like I was on the bus again, writing emails to people being like, "Hey guys, why doesn't RepRap and FabAtHome get together to write software?" You know, and that was yesterday. I haven't checked to see if they've replied yet. So this stuff is like it's right at the surface. Like again, all the interesting problems are right there, easy to grab a hold of, and you know, could use some help. So. All right. If there are any more questions, I'm going to call it good. Thanks for coming. I hope it wasn't too uninformed. So.
So I'm an industrial design student.
Awesome.
So like